Hi, it's Mr. Mac, and in this, our next in the series of Math Skills You Need, we're going to be evaluating non-linear expressions because not everything in the real world follows a straight line.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's Physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
So we're going to have a look at how to evaluate nonlinear expressions, and there are lots of useful equations that apply to a lot of science in lots of circumstances. Here you see the Parkes radio telescope, which is 20 kilometres north of Parkes in the central west of New South Wales, where astronomers use lots of complicated equations to gather information from the stars. What we're going to be learning is how to evaluate expressions that have non-linear terms. We'll be able to calculate complicated algebraic expressions with squares, square roots, trigonometric ratios, powers of e, and natural logarithms. Those words might be a bit unusual, but we'll see that the calculations are fairly straightforward. In our first worked example, we're going to be substituting into squares. The question is, evaluate the expression mv squared on r, given m equals 25, v equals 7, and r equals 14. So mv squared on r equals, just by substituting, 25 times 7 squared, all on 14. And we can put that into the calculator just as it is. So mv squared on r equals 87.5 from our calculator. In worked example 2, we'll look at evaluating expressions that have square roots. So this one doesn't seem to have a square root at first, but we'll see that the question is, evaluate v, given the equation v squared equals u squared plus 2as, and u equals 5, a equals 10, and s equals 3. So let's write down the equation. We're wanting to evaluate v, so we'll have to do something to the equation a little bit later. But we simply substitute. So v squared equals 5 squared plus 2 times 10 times 3. Calculating the right-hand side is 85, so v squared equals 85. Now we need to take square roots of both sides. And when we do, we find that v equals the square root of 85, which is 9.2195, and the digits just keep going. So we round it to 2 decimal places to have 9.22. Now there is an alternate answer, which is the negative of that number, but most times in the real world we'll be using only the positive. Example 3, we're going to use trigonometric ratios. So given the equation f equals qvb sine theta, evaluate f when q equals 0.5, v equals 25, b equals 0.1, and theta equals 30 degrees. So write down the equation, f equals qvb sine theta, and substitute. This is a fairly straightforward substitution. 0.5 times 25 times 0.1 times sine 30 degrees. But when we come to sine 30 degrees, we have to use a calculator to find the answer. And make sure that the calculator is set to degrees. If it's degrees in the question, it must have degrees on the calculator, and usually most calculators have DEG as an abbreviation. If it doesn't have that, you need to find a way to set your calculator so that it calculates in degrees. Calculating that, we end up with 0.625 is the answer. In worked example 4, we'll be looking at inverse trig ratios. And it's a word question, and it says, find the angle from the perpendicular when a force F of 20 newtons is applied to move an object S equals 5 meters using 50 joules of work W given the equation W equals Fs cos theta. And it may look difficult at first, but the first step is the same. Write out the formula. So W equals Fs cos theta. The next step is to substitute. And in this question, we replace W with 50, F with 20, S with 5, and simply times cos theta. On the right-hand side, you can see 20 times 5 is 100, and I can divide both sides by 100. 50 divided by 100 on the left-hand side is 0.5, and 100 divided by 100 is 1, so we're left on the right-hand side with simply cos theta. Now we need to find theta, so we need to do the inverse operation or the inverse function to get theta all by itself. So we need to write it as theta equals cos to the -1, which means it's the inverse cos of 0.5, and that will find the angle theta. And we can't do that without a calculator. So on the calculator, make sure you know how to find the inverse cos of a number. And it may mean using a button that's a second button, simply called second, or a shift, but it looks like that, cos to the -1. And when you use the calculator, you find that the answer is 60 degrees. So let's have a look at worked example 5, which has a complicated expression. Here it is here, but don't be put off by the fact that it looks a little bit difficult. It says find the value of t given the formula t equals t0 over square root of 1 minus v squared on c squared. And the values t0 equals 3.0, v equals 200,000, and c equals 300,000. Now, before we go too much further, there's a funny pronumeral there with a subscript, t0. It doesn't matter what it means at this point, just to understand that it's different from t. And we've got big numbers, and we've got a very complicated looking algebraic expression. But that shouldn't stop us from starting with the first step, which is to write out the formula. T equals t0 over square root of 1 minus v squared on c squared. And then we substitute. Now, in complicated formulas like this, use brackets to help. So I put brackets around 200,000 and brackets around 300,000, and note that the v is above the c, just like the formula. And t0 on the top line, we just replace with 3. Now, we can do that on the calculator. The whole thing can be done very easily, although we must make sure we're careful to use brackets when we have to, or that if we're doing it in one step, we make sure that everything is done in the right order of operations. And the answer you should get is 4.0249, and it keeps going. If you don't get that, use your calculator, try again, and make sure that you're doing the right order of operations. Now, we won't want to use all those decimal places, so we will round it. And to make the equal signs tell the truth and not lie, we've got 4.0 brackets correct to 1 decimal place. And it's important to state that every time. Well, let's look at worked example 6, where we're dealing with powers of e. E is simply a number, and it's number around about 2.7. But it's used so often that we give it a special letter e, just like we gave pi a special letter, happened to be the Greek letter. The question is to find the value of nt given the formula nt equals n0 e to the power negative lambda t, and the values n0 equals 250, lambda equals 0.1, and t equals 4. Now you'll probably notice we've got another Greek letter, which is lambda. It's like an L in English, but it's used in all sorts of contexts in science and physics. Now we've got two pronumerals that have different subscripts, so nt and n0, and we need to make sure we don't confuse the two. So we write out the formula. Nt equals n0 e to the power negative lambda t. So nt equals 250, simply substituting, times e, remember e is simply a number, to the power of negative 0.1 times 4. And you can do all of that on the calculator if you're careful. And again, just check that you can use your calculator to find 167.68 and the decimal places keep going. We want to round that. 167.6 correct to one decimal place. For worked example 7, we're going to use natural logarithms. Now, at the moment, it doesn't matter what those are. Just understand there's a button on your calculator that can find natural logarithms really easily. And here's the question. Find the value of lambda, given the formula lambda equals natural logarithm 2 over t a half, and the value t a half equals 5. Now, don't be put off by more complicated expressions. ln simply means press the button on the calculator, ln. It stands for natural logarithm, or logarithm natural if you want to put it the right way around. And the value t with a subscript a half is just like we saw before with any pronumeral with a subscript. It's just a way of identifying something called t a half. So we're going to simply substitute t a half for 5. So here's the formula. And when we do substitute, the top line is a number, log, natural logarithm of 2. But we substitute the bottom with 5. That next step we can do on the calculator. And we find out that natural logarithm of 2, so ln2, divided by 5, we get a number 0.1386, and it keeps going, which is 0.14 correct to 2 significant figures. Now, I've used the term significant figures in this case. I could have said 2 decimal places, but you can see that the 1 is significant, the 4 is significant, but the 0 is simply keeping the place. So it's 2 significant figures. We'll talk more about that in a later video. So we've seen how to evaluate nonlinear expressions, and there are lots of those in the real world. In our next video, we'll be expressing large numbers and very, very small numbers in scientific notation and showing how to round to a certain number of significant figures. I'm Mr. Mac. Thanks for watching.